All right, in this example, we're going to look at solving a system of nonlinear equations. Here we have x squared plus y squared equals 18, and we have y squared minus 3x squared equals 6. And the method I'm going to use for solving this system is substitution. So we're going to take the negative 3x squared and move it over, and that's going to give me y squared equals 3x squared plus 6. And so now what that tells me, it says anywhere that I see a y squared, I can replace it with 3x squared plus 6. And we're going to do that in the first equation. So that's going to give me x squared plus 3x squared plus 6 equals 18. Do you see that I replaced the y squared in the first equation with what it's equal to? And then I can solve for x. So let's combine like terms. That's going to give me 4x squared. I'm moving the 6 over. That'll make negative 6. 18 minus 6 is 12. Divide both sides by 4. And we get x squared is 3. Now, to get rid of the squared, we're going to have to take the square root of both sides. However, 3 does not square root nicely, so we're going to leave it square root of 3. And remember, when I square root both sides, I do need a plus and minus answer. So those are my x coordinates. Now, remember when we're solving a system of equations, what we're really looking for are the points of intersection. So now that I know my x's, I'm going to have to find my y's for my ordered pairs. And the way we're going to do that is we're going to take these values of x and we're going to plug them back in right here into this equation where we solve for y squared. All right, slide that up a bit. And that's going to give me y squared equals 3 times. Now, to save time, I'm going to plug in both the plus and the minus square root of 3 at the same time. And what allows me to do that is the fact that this is going to be squared. So a negative and a positive number, if I square them, they both become positive. And so that allows me to plug in both of those at the same time. Don't forget the plus 6. And then a square and a square root cancel. That's going to leave me 3 times 3 plus 6, which is 9 plus 6. 6 and 9 is 15. And then I'm going to have to take the square root of both sides. And again, 15 does not square root nicely. But when I square root both sides, I do need a plus and a minus answer. And those are my y coordinates. Now you need to understand that x can be plus or minus square root of 3. And y can be plus or minus square root of 15. And that's going to lead us to actually 4 ordered pairs. Here they are. It's positive square root of 3. Positive square root of 15. That's one combination. Or positive square root of 3 with negative square root of 15. Or negative square root of 3 with positive square root of 15. Or negative square root of 3 with negative square root of 15. And so this time, this system of nonlinear equations is going to have 4 points of intersection. And these are the answers.